Thank you all for coming and for being interested in Trajectools. Maybe before I kick it off, I would be really curious to know if any one of you has already tried the plugin. So if you could just have a short raise of hands if anyone has already tried it. I see 2 hands, 3 hands, 4 hands. Okay. So there's a lot of people here who maybe haven't heard of it before or who at least haven't given it a try yet. So welcome. Let's dive right into it. I don't know about you, but personally, I've always been interested in movement data since I first laid my hands on the first data set like 18 years ago, I think it is now. So anything could be bike sharing data in a city like you can see here on this small visualization, or vessel movement data in the oceans is really what I find very interesting and exciting to analyze, to look at, to try to understand the patterns and maybe to even make predictions about. So since roughly 2007, I've been working with all kinds of movement data sets, from vehicle tracking systems on the highways and in the cities to cell phone network data, all kinds of mobile app tracking, social media, Wi-Fi tracking, check-in data, all these things for all kinds of different modes, from individual people to objects to vehicles, obviously. What's the issue there? Really, it all sounds nice and fun, but when you start working with those data sets, you realize all the things that can go wrong with movement data. Basically, it's the best of both worlds from spatial data and time series data. So you get all the mess you can have with timestamps, with locations, with coordinate reference systems. All the things that can go wrong will go wrong. You will get coordinates that are not even anywhere in valid latitude longitude range. You will get IDs that are not as unique as they're supposed to be, so it appears like the same object is in multiple places at the same time. And of course, you will get GPS noise and all the other things that you will have to handle. So even if things are supposed to be standing still, there's still all kinds of jitter going on. So like in all data science, the reality is you spend way, way more time on data handling than on doing any actual analysis or, God forbid, doing some machine learning. That's the last 5% of the project. When you have to write the deliverable, then you finally have to train something with the data you have. And I really loved this statement from a couple years ago at the Carto conference. David, I think, nailed it, saying that space and time, those two data models really hate each other. So I totally agree with that one. So how did I try to handle the issue on the one hand side, being really into this kind of data, on the other hand side, it just being slightly painful every now and then. So the first thing that I try to do is to understand the data, just get a better understanding, to be able to look at it, to understand the spatial temporal characteristics. And that's when I started the Time Manager plugin, to be able to visualize in QGIS how the movement is happening in space. And I was really happy to see in the presentation beforehand also a couple of visualization created now with the temporal controller, which is like the successor of the Time Manager plugin. Then around 2016, I started writing a series of blog posts called Movement Data in GIS. And the early blog posts there, they revolve around using PostGIS to handle the movement data. Because there is like a rudimentary support for trajectory data types, you can do a couple of things with SQL, and it was kind of nice. But honestly, in my research team, whenever we got a new data set, I was like, great. So I'm the only person who wants this data in a database. I'm the only person who's going to put it in a GIS. Everyone else just wants to throw it in some Python script and get on with it. Nobody else is interested in this database stuff. So all the collaborations were kind of, complicated and not really the way that I would like them to be. So I set out to design something that would be more integrated with the workflows of the other data scientists, and that could be helpful for all kinds of projects, no matter what data set they would be throwing at me in the next couple of years. So on the wish list was, of course, flexible support for all kinds of movement data, no matter which coordinate reference system, or even data sets without coordinate reference systems. If someone comes up with eye tracking data, or I don't know what people are interested in 5 years from now, Then, of course, it should support all kinds of timestamps and reporting intervals. So no matter whether it's regular, like every couple of seconds you get a timestamp, or it's event-based, you get one timestamp yesterday, you get another one tomorrow, and then every 5 minutes, for example. Then I wanted it to be able to do some rudimentary plots that actually show the characteristics of the movement. So they might show the speed, the direction, and these should work in Jupyter notebooks because that's what most of the people wanted to use. They didn't want to take this loop all the time, go back into QGIS. But eventually, of course, the goal was to make it modular enough so it could be integrated in QGIS so that we could take advantage of the more sophisticated visualization options that we have there. So how has it been going since then? I started the project around in 2008, late 2018, when I really sat down and decided, okay, let's code something up. And interestingly, around that time, a couple of people had a similar idea. So you can see all those things taking off. It was the time when GeoPandas became serious. So everyone realized now we have the basis to work on something for programming something in Python. So we have Moving Pandas, we have Scikit Mobility, we have PyMove, and all the other projects that start around this time and have since been growing quite consistently. Moving Pandas is an OSGeo community project now, and we are already on release 0.23. So this is not even that much up to date anymore. But of course, you can find it on GitHub. And Moving Pandas is the underlying library that has all the logic that goes into Trajectools. So that's why I want to show you a couple of examples that people have done with Moving Pandas before I dive deeper into Trajectools. It's a bit challenging to know like who's using it, but I try to keep track of the publications that cite the Moving Pandas paper, and I have picked up just 3 small examples that I find interesting to share with you. First of all, of course, lots of people are interested in human mobility analytics. So in this paper, the team was interested in how to determine behavior of groups of people, where do they stop, how long do they stay there, and they built this analytics tool on top of Moving Pandas, stop detector, which was definitely one of the most popular algorithms in the toolbox, most often used, most often cited. Then another one is for actually training a predictive model. So they use Moving Pandas to segment the long observations of vessel trajectories into individual trips between ports. And then they use this information about the trips to the ports to train a model that can then predict vessel arrival times in the future. So here they would be using the tools to split the continuous observations into meaningful chunks that are meaningful trips between ports. And finally, the most massive extension of Moving Pandas that I'm aware of probably is this framework that was developed for analyzing drone movements. They really took all the tools that are in the toolbox, from the splitter to the stop detection and everything in between, for generalizing smoothing trajectories, and built this drone toolbox. So Moving Pandas has been rather developer friendly. We've seen a couple of external teams have already been using it, but the large challenge now was to make it also end user friendly for people who don't want or cannot code themselves. And that's why I finally made it come back full circle again, come back to QGIS, to developing Trajectools, which you can now find in version 2.6.1 already on the plugin repository. And when you install Trajectools, you will get a toolbox of algorithms for dealing with movement data. Most of them are from Moving Pandas, which you can tell by the icon, but there's also a couple of other ones which come from other libraries. We have GTFS functions for dealing with public transport data. We have an example of a privacy attack, which helps you to verify whether a certain data set is prone to re-identifying individual users in it. That's from Scikit Mobility, for example, and many more could be added to this setup. And like with all the processing algorithms, the goal is to keep them all modular so you can put them into workflows and automate your analytics. So let's have a look at an example. First one that is from movement ecology, and that I've also previously used in moving pandas. So it's migrating birds, basically, that fly from here around Sweden, Finland, Denmark, south to Africa for the winter. And of course, if you load this data set, all you see is a pile of points, and it doesn't give you much information except for the whole range that these birds travel. So what can we do? We can use Trajectools to enrich the points with movement information. So we can create the trajectories, and every Trajectools algorithm will have two outputs. One point layer, where every point will have information about the movement speed and the movement direction, which you see visualized here. So blue arrows are slow speed, red arrows would be fast speed. And of course, they show in the direction of the movement. And then there will be a second layer, which is a line layer, which basically connects all the points and which gives you an impression of how they are moving. So you can find out where's the origin of the movement, where's the destination. And in this data set, it's particularly interesting because it contains the migration patterns over multiple years. So this particular individual started down there in the south of Denmark, where it was tagged, and then it went down to the Arabian Peninsula and back to the north multiple times over multiple years. And of course, we can now use standard QGIS functions to look for this specific identifier, pick the specific individual, and then we can go back to moving pandas, for example, applying the stop detection algorithm, where we can say, what did I configure here? I want to find all the stops that are at least 1 day long, where the individual stayed in an area with a diameter of 15 kilometers for this 1 day. So depending on how big the circle here is visualized, the more days that birds spent at a particular location. And this way you can really explore the data. You get multiple output layers that you then can again use all the other algorithms in QGIS with to gain even more insights. And the second example I wanted to share with you is from our ongoing Emeralds project, where we're looking into urban mobility. And here we had the particular challenge at analyzing public transport data. If you have ever done any work with public transport data, I'm sure you are familiar with GTFS, the General Transport Feed specification. And it basically, the standard version contains the schedule. So it will have a layer where you can have information about the stops. It has a layer that contains information about the routes. And then it has information about every single trip that is scheduled. And luckily, there's already libraries that enable parsing of this. It's a glorified zip file full of CSVs, which you just have to pick out the information from. So this GTFS functions library that I have integrated into Trajectools here extracts this information and enables you to visualize the stops as a point layer. It allows you to visualize the shapes, which are the routes in the GTFS speak, and it allows you to extract the segments, which is the route between two consecutive points. So really from stop A to stop B, just this short segment of the route. And what this also does is, by default, it will already load with a nice styling. So you will see the route, you will see the names of the stops. And in the attribute table, you will have information about the duration of the travel between the stops and the speed that is in the schedule for this vehicle driving on this route. And our eventual goal was to compare the scheduled travel time to the actual travel time that was really observed. So the second part of the workflow then looked into the real-time GTFS. This is where it all comes back to trajectory data. This is where you get individual GPS points from the vehicles that travel on the road. So, in this GTFS real-time feed, we have information about the next upcoming stop. It's one of the attributes that is transmitted. And we use this attribute to split the continuous track of the vehicle based on this upcoming next stop ID, like you can see on the right-hand side. So every time the color changes, the next stop ID changes. This is not always exactly at the next stop, because if the vehicle just drives through because nobody wants to get off or on the bus, then it will be a bit off. But it's a close enough approximation of the whole thing. And this then makes it possible for us to compare what was in the schedule and what happened really on the in the real world. And of course, you can put this into the model designer, and you can automate the whole thing. What I have not included in this model is the process of pre-processing the GTFS data set, because that takes a while. You don't want to wait for that all the time. But you could put it as a first step in the box at the top, where we are loading the GTFS segments. And then in the bottom left corner, you basically see a couple of inputs that have to be specified for analyzing the real-time GTFS trajectories. So of course you have to tell it what is the field of the vehicle identifier, what is the timestamp field, if you don't want to hard code all those things and you want to keep it as flexible as possible. And in the end, in this case, we have some SQL magic that calculates the delays by bringing together the travel times from the real-time GTFS and the scheduled travel times from the GTFS segments. And of course, those can be visualized in the end. So we have calculated in the rightmost column that you see there the travel time lost in seconds for every segment. And then you can see on the map, like, where do the buses, in this case, lose most of the travel time. And maybe we have to take some action there. We can improve how the network is organized. So these were two examples of what we can do with Trajectools. Of course, many more things would be possible. As I showed before, everything that can be done with moving pandas, I think could be also replicated with Trajectools in QGIS. I wanted to leave you with a couple of other examples, because we also already see other integrations of moving pandas. The first one I was aware of is also from the domain of movement ecology. It's Move Apps. It's an analytics platform specifically for animal tracking data, which is hosted by the Max Planck Institute of Animal Behavior. And they originally started out developing this platform, which pretty much looks very similar to the model designer we have in QGIS, but it's online. It's for ecologists, and they started to build that on R. And later on, they realized lots of people also want to do their analytics in Python, and they decided, okay, for the Python side, we are going to use moving pandas data structures as I/O in and out data types, basically. And the second one we're currently working on in the Emeralds project is an extension for Carto. Carto you're probably aware of as a cloud-based spatial data analytics platform. And there we are also working on a trajectory analytics extension, which can be used to build also, in this case, they call it workflows, but it's basically a model builder to build up these automatic processing tools. So if you're interested in getting involved either in moving pandas or in Trajectools, you can find the code on Codeberg. For convenience, there's also a Miro on GitHub, but I invite everyone to try it out on Codeberg as well. And I'm looking forward to your questions or to having a chat afterwards with a coffee. Thanks.
Thank you.